We'll talk more about why climate data is important in our week 2. Okay, I'm going to fire this tool up. We're going to use a tool called Climate Consultant because this data is a whole bunch of numbers and no one can understand what it is. So they have come up, there are several programs that interpret these data and make it architecture proof.
Even you can understand. That's not good. You want?
Huh?
You want?
Slightly. Open the window. Okay. So this software is free to use. Everyone can see it?
I can see it. There's not enough contrast.
Light is a comfort, psychological.
Feel colder on
Cool, run, Stan. Alright, so Climate Consultant is a software that is free to use and it is available and it's developed by University of California, Los Angeles, I think, I don't know, UCLA. And let me point out a couple of things here. We talked about comfort, right? Tell you why that is important. Okay, we'll get to that. But here's the weather data file. Any climate analysis software would need the weather data file raw so that it can take that and show you in 3D graphics, which is what we like, right? So EPW stands for Energy Plus Weather Data, Energy Plus Weather Information. So that's another form like TMY. So in order to find the weather file, we need to go to a location that's available, that's from the Department of Energy. And I have that listed on a quiz, so you can go find that. But I've downloaded Phoenix information.
It's TMY2.
TMY2, correct. And the difference between, that's a good question, TMY, TMY2, and TMY3, the difference is just the year set. TMY is the earliest one. It was probably, I don't know, 60 years ago. TMY2, 30 years ago. TMY3 is the latest. So if you can get TMY3, always go for that. That's the latest information. So I'm going to open Phoenix.
Global warming, the weather has changed over time.
It is very important to get the latest information, and we will look at that a lot closer on the next week. Okay, so this has a whole bunch of screens, and I'm not going to focus on all of them, but a few that I think is important. So, talking about comfort models. As you see, there are several types of comfort models. And again, what goes with comfort model? A set of defined parameters. It is important for us to understand which comfort model we are designing to and what those factors assumed within that comfort model is. California, they have their own comfort model. This is what we always do, ASHRAE, right? This is becoming more and more common now. ASHRAE 55, lead buildings want us to do this. And PMV, this is something we'll talk about in one of these weeks. PMV stands for Predicted Mean Vote. We'll talk about what that is in the next few weeks. Then last one, Adaptive Comfort Model. This is very important to know, especially when you're starting to get into international work. The reason is, how many of you, this morning, the weather is pretty nice in the morning, how many of you remember seeing anyone on the street with your windows rolled down? One? Right. It's very nice outside. Why are we not doing that?
noise.
No? Higher level of comfort in America. In other parts of the world, the level of comfort is so different. There are so many different factors that impact comfort. Because there's economic, social reasons that impact cultures too, impact the comfort level. And that's what this adaptive comfort is for. This comfort model is to help define those different cultures, those different set of parameters from North America.
Taking those climate
It depends on each climate. They allow you to tweak those parameters. Because here, they set these parameters for you. This is it. That's what you're designing your building for.
Okay.
But here, they allow you to change those things. Right, and we'll look at how. So I'm going to use a traditional comfort model, ASHRAE fundamental books.
You said that these take into account, like especially that last one, some of the psychological factors?
Not necessarily the psychological factors.
Okay.
I think it allows us as designers to input the local metrics, cultural metrics. Okay, so I selected ASHRAE fundamental, and you can see here using ASHRAE Handbook 2005. It's old, but I don't know if it's changed since then, Terry. But look at this, 68 and 74. These are the first two numbers we should always look at. 68 and 74. Is that what you're designing your building to? Not necessarily, right? What are you designing to? We're designing to 70 and 76. So very important two fields to understand. Ask the question to your owner, what are we designing to? What can you be comfortable with? Can I push it to 76? Can I go to 66? Ask that question. I'll tell you why it's important.
I don't know if you know the difference.
Huh?
I don't think you discern the difference.
Then let's push it.
Well,
Let's save more
I
energy.
think when you're going to ask us what they think.
They don't know what you're
Well,
talking
they,
They're not going to know the difference between
on one for
Some clients do.
on PV32,
Paradise Valley will.
Paradise Valley, they said they
Scottsdale
gave
will.
right, they gave our design comfort level.
But from the standpoint of cost.
No, from the facilities people, correct. And that's where those facilities people are setting up the controls programs and having those set points in their control system. This is where they set it, and then let the teacher go 2 degrees up or 2 degrees down kind of thing, right?
Right. So they are designing, PV32 is designing for 70 and 76.
Correct.
So 76, there's 2 degrees difference. They already stretched it, right?
Yep.
Okay. And each week we'll use this software. Yes.
Did they truly stretch it if they raised both of them 2 degrees though?
With the amount of cooling degree days that we have in Phoenix, definitely.
Okay, for this
Relative
climate,
for this climate, correct.
But if you still keep that 6 degrees, I guess it depends on where you're at.
Very true.
Yes, that's what the software is going to help you understand.
It's low.
Is it a cooling dominated climate from just an outdoor condition, or is it heating dominated climate? Right? We'll look at this.
So yeah, in Nebraska and Iowa, they would try and stretch it on the other side.
Exactly, it can go either way.
Right, right. So
Yep.
knowing where you're at has a big impact on where you want to stretch it.
Well, if
Right.
you're,
Have an impact.
say, Nebraska or Colorado, where you have a high heating demand during the winter and a high cooling demand during the summer, if they keep that 6 degree separation between the two, is it truly stretching it, or would you want to go to a 10 degree separation between them for your comfort level?
It'll be very easy to understand that from just an outdoor design condition using